So today we'll be figuring out where to place a negative charge between two positive charges so that the net force on the negative charge is 0. We place charge 1 at position 0, and that charge is positive. We place charge 2 at position A, which is 5 meters. This charge is also positive. And then we're going to place charge 3 somewhere in an unknown location x between charge 1 and 2. This charge is negative. So we see that charge 3 will be attracted to the charge 1. It's to the left. And we see that our negative charge 3 will be attracted to charge 2 as well, but that'll be to the right. And we want to place our negative charge just in the right place so that those two forces cancel. So let's first use Coulomb's law to find expressions for force 1 and force 2. So force 1 is a constant k times the product of, or the absolute value of the product of the two charges, q1 and q3, divided by their separation distance squared. That distance is x. Also, we indicate that force is to the left with a negative sign. And that's sufficient to indicate direction in a one-dimensional problem like this. Force 2 is to the right, so in the positive x direction. We have k times the product of the two, the absolute value of the two charges in question, divided by the separation distance squared. And that's Coulomb's law for point charges. So now we see that the net force on charge 3 is just the sum of the two individual forces. And we're going to insist that that's equal to 0. Notice that this expression, on the left, k and q3 is a common factor in those two terms. This means we can factor them out. Since the left-hand side is equal to 0, we can go ahead and divide by these non-zero numbers to get rid of them, and we are left with the expression. Also, we can drop the absolute value bars because we were told that charge 1 and 2 are both positive, so we don't need the absolute value bars. In this problem, the amount of charge 1, charge 2, and position A, which is given. A is 5 meters. So the only unknown is x. So we have an equation in which we can solve for x. I'll move the negative term on the left to the right-hand side by adding it to both sides. I'll divide both sides by q1 and multiply both sides by x minus a squared. So notice that the right-hand side can be written as x minus a divided by x quantity squared. We can get rid of the squared by taking the square root of both sides. You just have to remember that the two solutions are going to be plus or minus the square root of q2 divided by q1. Also, the term in the denominator, x, can divide the two terms in the numerator on the right. So we get x divided by x is 1 minus a divided by x. So a divided by x will be 1 plus or minus square root of q2 divided by q1. And finally, cross divide, so to speak, to solve for x. And we see that here we get two solutions, except only one of them will be valid for our problem, as we want charge 3 to be between charge 1 and charge 2. So x has to be between 0 and a, or 0 and 5 meters. Okay. So maybe we can plug in numbers. A is 5 meters. Q2 is, if you look at the problem, actually, you can plug in numbers, but you notice that charge 2 is half the amount of charge 1. So Q2 divided by Q1 is a half, and we get two solutions. X is 5 divided by 1 plus the square root of a half, or x is 5 divided by 1 minus the square root of 1/2. The first solution gives that x is approximately 3.93, and the second solution gives us that x is approximately 17.1 meters to 3 significant figures. So obviously only one of these makes sense, as we needed to place charge 3 somewhere between charge 1 and charge 2. Now, as an alternative, we could have used the quadratic formula. Cross multiply, expand on the right-hand side, and then bring all the terms to one side. That way, you see that we have a quadratic in x, where the coefficient for x squared is q2 minus q1. The coefficient for x is negative 2a q1, and the constant term is a squared times q1. And according to the quadratic formula, x is the negative, well, I'll just write down the quadratic formula, and then you can plug and play here. Plug in the numbers, since you know q1, q2, and lowercase a. And again, the formula might give us two values of x, but only one of them will make sense in the context of the problem. Well, thank you for your time, and we hope to see you in Peer Tutoring's virtual drop-in lab.